Hello, hello. We are at part 2 of our developer mini bootcamp. So I'm Emily. I do DevRel for Linea. We have Mateus here. Please introduce yourself.
Hello, people. I'm Matheus Pagani from Venture Mine Academy.
Okay, cool. So if you guys aren't familiar, we are running a monthly hackathon on the Linea side, and in preparation for that, we're doing, what do you call it? I guess this mini bootcamp series. We had part 1 on Saturday with Mateus, which was amazing. We went through smart contract basics, and then today we're doing a full end-to-end dApp using Scaffold ETH. And hopefully throughout all of this, you'll learn how to build something new and then want to take it further with a hackathon. So I don't have anything else to say. Otherwise, Mateus, if you want to take it away, I'm going to hop off the call and come back again at the end to wrap
Hop off.
everything up.
Got
Hop
you.
off. Yeah, they're doing some frog themed stuff today, which is exciting. Croak,
Very
croak.
good.
Yeah. Okay.
Thanks a lot, Emily. Hello, everyone. Today, we're going to bridge everything that we learned about smart contracts to finally use something in the front end, deploy something, a dApp, and all of that, right? So we are out of excuses not to ship a dApp, not to ship something. We are totally equipped now, empowered to bridge the gap for our end users to interact with our smart contracts and all, right? Because the whole idea when we make a smart contract, it's all decentralized now, but the whole idea is that now people can use a smart contract without being so technical, without going over a training, without going over 3-4 hours of training to like we did to communicate with the smart contract, right? We're going to understand that in depth. So let me start sharing my screen, get everyone on board. And if you are here live, listening, following us, send me a message here. Now I can see the chat. Send a message here, send a croak, send a hello, send a GM, as you would prefer. We are going to start the part 2. If you did not watch the part 1 yet, it is here. The link is here in the same repository. You're going to find this repository's link in the description of this video. Okay, so you can have access to the same material if you want. Let me decrease the zoom a bit. If my screen is not readable, or if you're confused in the navigation and all, please let me know. This is an interactive lesson. If you have questions, I can see them here in the chat. Also, I have explained it last lesson that you can use the issues tab to come here and ask a question. I'm going to speak about this as well. Okay. So pick this repository, pick this GitHub link, and follow us back down here up to the part number 2, this part that I'm going to introduce you all about the app development. Okay, good. Where is Emily? Emily has opted off, but she's listening. Okay, you all come here for Emily, and then you find me. Okay, I get the idea.
I'm here. I'm here. I'm in the background. I'm just monitoring. Mateus is the one departing all the knowledge. Okay.
See, Emily, they love you. That's the
Oh,
part.
yeah. They love me too.
So Emily is here. Thumbs up. We are ready to crock our way to development for Linea. Okay, one hop at a time, one knowledge hop at a time. Okay. So without further ado, let's understand what we are doing this mini series of 2, right? We started our journey in understanding solidity and blockchain development last lesson, where we did this first this first iteration of a deployed smart contract that was a frog that can jump. That's it. A frog themed version of the counter the counter template smart contract that you can find in Remix, you can find in a lot of documentations, that instead of just increasing a number without any meaning, we are doing this number as a jump counter, the amount of hops this little frog did. And we did that in a way that we could make the frog jump for free, just paying the transaction cost, of course, and then we make the frog jump by paying. And then we understood the dangers of solidity, the dangers of roundings, and all the dangers of not understanding solidity, actually, what is under the hood. So this was more like an appetizer, introduction to the theme yesterday, and then we moved for the token part. The last few minutes of this first lesson, Saturday's lesson, were very hasty. So I want to point attention here for the solution for that problem of the ERC20 token deployment. That is real quick, okay? That we are going to do the same thing to deploy smart contract as we did in the last lesson. If you want to deploy this token, okay, increase the zoom a little. This is what we did. But the problem is that when we are using the London version of a virtual machine, that is also the EVM that is running on Linea, we need to run the smart contracts up to the version 0.8.19, right? And this was the problem we were having on Saturday. The solution is like this. We should pick an older release of OpenZeppelin. The number 4 is stable, is good, is up to date, and we have everything we could possibly need for making tokens. But instead of picking the default branch, that would be the latest release, we would need to specify a branch for this release of v4.9, okay? So this would enable us to compile and deploy a smart contract to the London EVM and to the Linea blockchain using OpenZeppelin contracts, okay? And then you can keep on everything we did last lesson. Let me demonstrate that for you because it's going to be important for today's lesson that we have the frog token and the frog smart contract for using, because the intention is to build a dApp, a front end for these smart contracts. We're going to get that later. So I have these workspaces from the last lesson, Saturday's lesson. That was Linea Test and Linea Tokens, those two workspaces. Here I have this contract frog token with the updated fix. As you can see, I'm not importing it, just default import, this one. We are not using this default import as we did. We are now changing for the actual branch, release 4.9 branch of the OpenZeppelin contracts. Then when I compile this with the 0.8.19, I can compile this, I can deploy in the London. Here I could even fix the version to 0.8.19, would be even better. And then I can deploy this and interact, okay? Yesterday we couldn't. We couldn't do this, and nor that, and all. And if I connect to MetaMask to Linea, let me unlock my MetaMask. This is all about Saturday's lesson, okay, people? If you just joined it today and didn't participate on Saturday, that is no problem. Just wait for a couple minutes until we get there. Let me go for the testnet of Linea Sepolia. And look, now when we connect to it, since we compiled in 0.8.19, now we can deploy this frog token to Linea, okay? That was the only thing missing on Saturday. Now that it's fixed, you can apply this thing for any time you want to import a contract from OpenZeppelin for Third Web, for any other library you want to import. You need to remember that we had a breaking change on 0.8.20. That was the push 0 opcode. So this fixes it. We have our smart contract working, okay? And also another point that is interesting to review is that we deployed those smart contracts of the frog jump on Saturday. We have one of the students here that shared his smart contract address in this issue here in GitHub. If you have a smart contract deployed for the frog jump smart contract, do post here on the issues as well. I would love to see, I would love to interact with your smart contracts. And my intention is that we discovered this. When we attach a smart contract, frog jump, or even iFrog, iJump interfaces to an address in a public blockchain, we can interact to it to get the name. Crazy Frog Dance, what a great name. Jumps, 100 jumps. Okay, and perhaps this should be the payable version. If I try to jump without paying, that's probably going to fail, or it's not going to jump at all, because it's going to divide 0 by something that's going to end with 0, right? So this is the first part of today's lesson. When speaking about front end, let me get to the material again. Oops, returned too much. This is the link I want to click. When I return to the material, when we start speaking about front end, part 2, okay, build a front end with ScaffoldETH, we are speaking about building an interface, okay? Ideally, your front end wouldn't have any core, meaning any core functionality of your dApp, of your protocol, of your application, and all. Sometimes we can even deliver value with a front end. What I mean, for example, if it's a game, I can deliver the value of entertainment with the front end. If it is a project to gatekeep the artist videos and audios and all, you could even gatekeep the playing of the video, playing of the audio itself. You see, the front end could even deliver value, yes. But the monetary value, the ownership value, the value that needs to be decentralized, always need to be in the blockchain. Always need to be in a trustless environment, because a front end can always go offline. A front end can always be modified. A front end can always be subject to change, to centralized censorship, to firewalls, and all. A blockchain cannot be censored, but a front end can. Actually, a blockchain can be censored as well, but it's much, much, much harder than just a front end app hosted somewhere. Okay. So this kind of architectural this kind of architectural realizations about front end, about interfaces, we can already start experiencing here in Remix, for example. If we attach an interface iFrog to that address, an interface iJumper, iPayable jumper to this address, and now, no matter what I do with the interface, even if I change the interface and all, the smart contract is going to behave the same. Okay. Do you all see that? Is that clear? Even for beginners, even if it's the first time of you interacting with a blockchain, is that clear for you? That anything that we do on top of these smart contracts now is quite safe. It is decentralized, it's trustless, because of the engine of the application is running there on chain. Is now is a smart contract on chain. Often people put important parts, monetary parts, or trust parties and in the front end. For example, centralized exchanges. And we see what happens when we have an application, a backend and a front end, hosting sensitive data or important data, right? For example, FTX. Unfortunately, we have this happening, people. We did BFT, Byzantine fault tolerance, means that there is going to be fault. It can be fault in a front end, right? And it shouldn't impact your business. It shouldn't impact the app, your protocol, your decentralized game or whatever. If your front end is faulty, because the funds should be safe there in the blockchain, right? So that being said, now that we know that an interface is just that, just an interface is just a shell on the sides of this core of this smart contract. We are going to make this interface to behave as neatly, as intuitively, as fast, as beautiful as possible to attract as many users without giving up the decentralization part, without giving up the trusted part. Okay. So how to connect the best of those two worlds? An user that is accustomed, that is used to the Web2 experience of just logging with an email and password and that's it. And the other side, you need to have a private key, you need to have a secure signature, you need to have ownership, you need to keep track of your mnemonic, and because no one can retrieve that for you. How to pick the best of those two words, the intersections. Then I'm going to show the correct techniques, the correct tools and techniques, the best ones that we have available nowadays, I can say, to build this front end, to build the app for us. Okay. You can find the GitHub link in the description of the video, and I guess we do have this link. Where should I? Okay. I should have made a QR code or something like this. You're going to find in this URL venture dash miner. That's my company where I have my academy, and then you're going to have Linea Dev Cook-Off Mini-Bootcamp. I'm quite sure you're going to see that in the description of the video, in YouTube, in X as well. Okay, just follow with us in this link, and then let me guide you into the first steps. Okay, actually, for building a front end, if you have tried building front end in the past, this part I'm going to say can sound repetitive. Sorry about this. But for all of you that never did front end code in your life, our goal here, our objective, is that we can provide these kind of interfaces, we can provide these kind of experiences for our end user without installing anything, without downloading any app, anything to their own devices and computers, by using a technique that have been there for a few decades already, that is using a web browser like this one that we have, uh, uh, an internet connection and web browser to access an URL where you are going to download HTML, CSS, and JavaScript files. For example, GitHub. This application, did we install GitHub in our machine, in our device, in our phone? This application is loaded through the web. This application is loaded through the browser. And what we have here, let me inspect here. What we have here is a huge HTML file. See, this is HTML. It has those tags: HTML, head, body, div, p, h1, hypertext markup language. This it's not a programming language at all. Okay, I know HTML5 can do a lot of cool things, but it's not a programming language yet. It's much more a text file. It's much more a spreadsheet than it is of a programming language. It can trigger some parts of code called JavaScript inside the page to do something, but the idea is that it is some bunch of static files that you can download and can do things on your browser. For example, if I change I guess I need to zoom off a little. If I change the style here of this page for having a background color, a different background color of, let's put it red, very ready. Did I change GitHub for everyone? Did I hack? Did I hack GitHub? No, it's ready for everyone. No, right. This web application is loaded in my browser. See, this is an HTML that I can change. I can edit. I can view the variables that are there. I can change the variables. I can even change how it works. Okay. So our goal for building a front end is building some HTML files. So for that, why I'm speaking all of this, for building HTML files, you don't need any prereqs, okay? Yeah, starting from the basics. The idea of this bootcamp is to have everyone on board, okay? No one is going to have excuses of not shipping or not building. We are starting from the beginning, so I just arrived at the prerequisites part. But for building HTML, we don't need any of those tools, okay? We don't need to install anything. Let me show here an example of something that we can do, okay? I have a folder here in my computer. This is my terminal. Today we're going to use a lot of our own environment, okay? Let me start with a simple HTML file. I guess I can even create here in my with a folder before I start here. So I can create a new HTML file. I'm using Manjaro Linux here that has this interface. If you are in other distro of Linux, if you are on Windows, on Mac, you are all going to have a way to create a new file and name it HTML there. Okay, name it something .html on your device. And when I change the content of this file, let me open this in a code editor, okay? Using my terminal here, but if you don't know how to use your terminal, don't freak out at this point. You're going to need it more later. I'm just demonstrating something now. I'm going to list the files that I have. I have that folder where I have this repository, and I have this new HTML file. I'm going to open it with code. This HTML file. Okay. So this is one text editor, one IDE that I have in my computer called VS Code. If you have others, it doesn't matter. It doesn't need to be VS Code. Okay. Anything that I put here inside this HTML file that looks much more like a text file than a script file. For example, if I put something here inside the body, if I put a paragraph like this, and like frogs go croak. When I open this in my browser, we spent like 2 minutes here, don't know. When I open this file in my browser, open this with Chrome, I have this content already. We code the front end. You can do that without installing any tools, without installing Node, without installing Git, without installing anything on your device. This is already web development. You can deploy this to, you can serve this HTML file as an index file or whatever, and this can be your website already. Okay, you can put more things down here. You can fill your HTML with code. Okay, let's see if I have Copilot here. I guess I don't have it because I'm in trusted mode. We trust this file. I just created this file. If I don't trust myself, who am I going to trust, right? Trust. So let me ask Copilot to do some content here. No, Copilot, you made a very bad suggestion. So let me put myself. Copilot is not helping me today. Let me put an H1 that is going to be like intro to coding with frogs, whatever, frogs. This is our experience with coding the HTML ourselves. Everything we do here in the file, we now can see happening in a browser when we open this file. But the changes that are happening here, see, here we have this H1, that is a tag for a heading, something that is going to be bigger, bold. And here we just have a paragraph, something that is going to be smaller and normal text. Okay, this is interpreted by the browser. Okay, not only visually, people. This is very important to highlight when we speak about diversity and inclusion. There is a lot of people that access websites not to see, not to view the content. Okay, but they use, for example, listeners, web listeners, because, for example, sight impaired or using accessibility tools or even bots. And these tags have semantic meanings as well. They can be understood differently by those audio readers, for example, for people that are sight impaired. So when you are building a website in HTML, you're not just building something visual, you are building something semantic as well. And the visuals here, to be honest, are very poor. We don't have not even one image of a frog here yet. And the things we want to do with the coding path, they are also actually very complex to handle all of these connections. And now I would need a few weeks to cover building an HTML from scratch with JavaScript and all for building a dApp. So instead of doing that, now we know what web development is building these HTML, putting CSS and JavaScript could be done as well. But instead of doing this, we're going to ask not an AI, not yet. We're going to ask a framework to build this HTML for us. It is like going for a restaurant and you order the food. You should say what you want. For example, I want pasta with this topping and a side salad and all, and that's it. You give some broad directions, but you don't micromanage the cook on putting the actual ingredients in. And all right, you just give some broad directions, and then the people in the kitchen, they know what to do. You can do the same metaphor, for example, in a bakery. Someone is baking you cakes. Yes, I love food metaphors. So instead of writing this whole HTML, CSS, and JavaScript ourselves, we're going to use a framework to write this for us. And for that, we're going to need to learn how to deal with the framework, okay? But it's a good trade-off. We learn a little, we invest a few hours in learning this framework, and quickly, in the first dApp that we do, the framework is going to save so much time that it is already paying off. It is already compensating to invest this time in that direction, okay? So instead of writing this from scratch, we are going to use a framework. For using the framework, so I'm going to close this HTML file. We're not going to use it anymore. I'm going to close Remix as well. Not going to use it anymore for now. Instead of writing the HTML, we're going to use this framework. But for using a framework, we need to install some tools. Because ScaffoldETH, we're going to look at that later, it runs using React with a framework, React framework called NextJS. And this framework is meant to be run, to be executed for building the files and using all of the tools of that, using Node. So for example, we would need to have Git CLI for downloading the repository, but it's possible to download without Git. We would need Yarn to run the commands, but you eventually could run the commands with other packages as well. We would need VS Code for editing the files, but again, you could use another editor. But we cannot go without. There is no other replacement if we don't use Node or Bun or some engine for running this package for us. Okay. So at least these tools you're going to need in your environment. Okay. So if you don't have these tools working in your environment, please let me know here in the chat. Send a message here in the chat or in YouTube chat or in Twitter. Or if you are listening to this lesson in the future, uh, you can open the GitHub issues as well, can try and troubleshoot. But some of the comments that we're going to need require that you have this working in your system. So for example, you should have some terminal, some shell, some bash there that you can access in your environment, that you can do this kind of command, an ls to list the files, for example. And you should have a folder set up in your separated in your environment for you to start coding this lesson. If you mix up this folder with another folder in your computer, you could have problems later on with yarn, thinking that you are in a sub package and now. Okay, so you should have access to your terminal. Should open your terminal inside a folder that is safe for you to use in this bootcamp, in today's lesson. For example, here I'm in a folder called Linea in my desktop. I know that it's clean. I can create new things inside of it. Then the first command that we are going to run is git clone. So the first command already requires a package, a git CLI package. This is the link for it, okay? For you to use the command line interface of Git to download files on your computer. If you don't have it installed, you should install it as soon as possible. But it's also possible to download from the GitHub repository itself. Just paste it on your browser and you're going to have this option here for downloading a zip version of it. It's not very good, but can be a workaround if you don't have Git installed. If you have Git installed, since it is a public repository, you don't need to set up anything at all before. You just need to paste that command in your terminal, in your shell, in your bash, and then you can execute it. This is going to use Git in the operation called clone to download all the files from this repository, and it is going to be stored in a folder in your computer. A while ago, I had this HTML file and I had this folder. Now, if I list files again, I have a new folder with everything that was downloaded from this package. Okay, now I'm going to enter this folder, ScaffoldETH 2, and I'm going to list the files to see that there are a lot of things downloaded there. Okay. Speaking a little about ScaffoldETH now, what is this that we are downloading? Is this a virus? Is this a computer program? Is this a library? What we are downloading here? So a ScaffoldETH is a scaffolding tool. It is a tool that is going to give you out of the box all of the needed components, all of the needed parts that you can use for building your own dApp on top of it. Okay. If you don't need some of the components that are included there, you can even cut them off later. You can remove those scaffolds parts later if you want. But out of the box, it has everything. We can run it now and have some sort of interface like this image here with everything that we're going to need set up. Namely, we are going to have NextJS, a framework for building React, React is the leading library right now for web development. Instead of you building those components, those pages, HTML, CSS, and all from scratch, you could use React, but React is a library. It is meant to be used as a library where you can take more or less of it when you want. And this requires a good knowledge on React. You should know React to decide what you want to take from it or not, right? So using Next.js, that is a framework built on top of React, you have everything working on the React side out of the box, pre-configured with the configurations, conventions over configurations. There you have path resolution. You have the part for serving this application with server-side rendering with serverless functions. There is a lot of cool features, edge features, like bleeding edge features of web development that you want already there. So even these things that you might not even know about are there, ready for you to use inside your the app without having to code this yourself, all inside Next.js, okay? Because it's optimized for performance. It is a little more difficult to handle than all the frameworks or the options, but nothing that we can't handle in this lesson, nothing that we cannot go over, okay? In this specific settings of ScaffoldETH, we have Next.js with a CSS framework called Tailwind as well, with some custom components in a library called DaisyY. So everything you need web development related for building the front end, making it beautiful, responsive, quick, and all is there. You have Rainbow Kit for helping you to connect with wallets. Hard Hat, that is a super tool for the smart contract development, doing scripts and tests, compilation, and all. Also works with Foundry, if you know Hard Hat and Foundry. Works with both. Wagmi and Viem. Viem is a library for abstracting the connection to the blockchain and the blockchain objects like contracts, like wallet clients, public clients, and different utilities that you might want. And then the Wagmi wrappers, React wrappers and wrappers and core that you can put on top of Viem for using in Next.js, and all with TypeScript settings, TypeScript enabled. Okay, so instead of using JavaScript, plain JavaScript that has an inconvenience of being like too open, too permissive, and when you do something wrong, it allows you, okay, let's roll with it, and then you happen to have all of these errors when you run your app. Instead of doing that, we are going to use TypeScript. So we have checks in place. We have uh, uh, typings, bindings, ongoing checks while we type, while we code. And so it's going to provide a much better developer experience, learning experience for us. Scaffold ETH has all of that working out of the box. Okay. For the little price of you understanding it and doing the prereqs for installing it. Okay. So when you clone, you have this starting version. It's not a library like OpenZap libraries that we're going to pick things from it. No, it is a starting point, a boilerplate. Is a boilerplate dApp for you to connect with smart contracts here, okay? So this is what we are cloning in our machine. For us to install it, we're going to need another package called Yarn. It should be accessible in your computer. It's one of the prereqs for today. The installation and how to instructions are here. You should be able to install with Core Pack in your system. If you don't have Core Pack enabled, if you install, for example, with npm or any other tools, you're going to install an updated version of it, like the version 1. That is still able to use, but it's much slower. Okay. This way, you're going to install the correct version of it, and then we are going to run this command, yarn install. Okay, I've cloned it here. I've entered the folder, and then I'm going to do yarn install. That is going to need yarn. Yarn also requires Node to run. So if you don't have yarn installed, you are going to need, what's happening? You are going to need, anyway, do those steps here that I have in the documentation. Okay, this command yarn that I run out there took almost 13 seconds only, needs Node to be installed on your computer. Okay, if you are in Linux or Mac OS, I suggest that you use this tool called a Node version manager, because if you have your Node in a different version than the Node version 20 LTS, that could give problems. For example, let me see my Node version at the moment. It is 18.18. That is wrong. For example, let me see if I have Node version manager here. Yes, I have. So instead of using version 18, I can use this package called nvm so that I can install, for example, install the LTS version that is going to pick the latest LTS version, that is the version 20.12.2. And then I can make my environment to use this version of Node, nvm use LTS, like this. Okay, now if I do again the Node version, look, I have the Node version 20. Okay, that is the quickest and easiest way that I know of for managing Node versions. If you have different programs that need different versions of Node, that can really solve that quickly. And also, if you have these problems of, hey, Node only works with sudo in my computer, or Node is giving me some weird path errors. So this is the easiest way to solve, because when you use nvm, you don't need sudo, you don't need super user permissions for that. Okay, so it's really quick and easy to use. For example, if I do yarn, oh, I don't have yarn anymore in this Node version. Oh my god, that was not planned. Let me solve this now by doing the car pack enable. Okay, and now I should be able to do yarn install. Okay. Now all good. Now we have my environment set as expected. Okay. I was thinking I was in Node version 20. Okay, but now it is solved. You see how it's quick to resolve these version problems when you use nvm. This could take by itself half an hour if you follow different paths. I could resolve here in my system very quickly. Do check that in your site as well before progressing with this lesson. See if you do have the version uh, LTS 20.11, 20.10, 20.12. All of these are good for using today. Okay. If you are on Windows, it is possible to code, develop blockchain and all anything you want on Windows. Okay, there are good tools. There are recent version, even without using WSL, like on Windows itself. For example, you can use this community package from Cory Butler and set up Node versions in Windows and use it in your terminal, in your PowerShell, as you would use in Linux. Okay, there are some small differences from the NVM for Linux, but it's going to do the same thing for you. So you can use Yarn, you can use Node, you can use everything on Windows. Okay, in Mac as well, but Mac is the same instructions for Linux. Windows, you're going to use these instructions here, for example. And then you're going to be able to run this command of yarn install. You're going to have yarn there. And then you can run all of those other commands as well in your machine. Okay. If you still have problems with that, Please don't hesitate in opening issues here at the GitHub, so I can point you some directions and try and troubleshoot some things that might happen. And we are ready to start. We're ready to start coding, ready to start running and rolling with this package, with ScaffoldETH. The first command that we are going to run after installation is yarn chain. Yarn chain. That is going to use ScaffoldETH tooling, ScaffoldETH scripts that were programmed there in something that we're going to see later, the package.json, to run some things in a machine. Oh, so ScaffoldETH can be used as a program, like a binary sort of thing that we can run things on a machine as well? Yes. One of the things that we can do is yarn chain. That is going to upload a virtual machine blockchain sort of in our own environment, and it's going to host it at an endpoint at our local host for us to interact it. Now in my machine, in my computer that I am now, I have a local version of Ethereum running. And also I have all of those pre-funded accounts, 20 pre-funded accounts, each of these with 10,000 ETH on them. Oh my, that's quite a good amount of money to have access to. And the private keys of these accounts here as well. Okay. This is meant for testing purposes, okay, people? You can't run any production sort of application in this test blockchain, okay? If you want to run a node of a blockchain in your computer connected to mainnet and testnet and all that, there are plenty of instructions for this. But for this lesson for today, I intend for us to use these local nodes only for testing purposes. And then let's proceed by running the second command. But there is a thing here, people. For running our second command, that would be yarn deploy, our terminal is busy here. We can't type anything here, like ls, whatever. If I try to do any command, cd or whatever, it's not going to work because my terminal is busy processing that command, processing this yarn chain. So if I want for it to accept all the commands, I would need to stop the execution. Usually we do this with like Command C in Mac or Control C, depending on your keyboard, like Control C is going to stop execution for me. Okay. Now I stopped that execution for the yarn chain. Now I could do the yarn deploy. Yes, I can run. I can ask my computer to run. But the problem is I need the chain running. If I do yarn deploy now, that's going to give an error. I can send this command, but I need the chain running for that. So the easiest way to do this is having two terminals. Instead of doing a multiplex, whatever, pass a command to the background and all, it all could work, but it's quite complex. An easy way, for example, is to have two terminal tabs. Or I can even, for example, using this ZSH console that I have here, I can have a split version left and right. Okay. Let me clear this here. Clear, because I don't need this much zoom. So left and right versions of the same terminal, where in one of them, in the left version, I can do yarn chain, for example, and I have the blockchain running. And then in the right pane, I can do yarn deploy. And this right pane execution is going to run a script as well as going to run some operations programmed by the people that are maintaining ScaffoldETH. And everything that is done here in the right, we are going to see reflecting here in the left. For example, here I deployed a smart contract called your contract. We're going to see that later. and we saw those transactions being sent here. An estimate gas, a chain ID, a get transaction count. All of these calls were made by this script so that I have sent this transaction for deploying that smart contract, used some gas. I don't need to fetch gas from a faucet here. All of those pre-funded accounts, they already have 10,000 ETH on each for paying transactions. And then I have these transactions included in the chain. We have an auto mine uh, behavior here. Every time I send transactions, we have a block mine just for that transaction, just for us. Okay, so it's a blockchain entirely dedicated for anything that we are running. We don't have blocks being produced for all the people here. It's just for the things that we are running. And at the end of this execution, we had a smart contract deployed and a transaction sent, and we have the descriptions of what happened here in the left pane. Later in this lesson, we are going to do all the on-chain actions as well. We are going to do all the operations like sending tokens, asking tokens from a contract, deploying contracts. You're going to see those transactions happening here in the blockchain console as well, the description. Okay. So we are up to this point, yarn deploy. We did yarn chain. We just completed yarn deploy. The last step for setting up is using this command of yarn start. That is going to spin up the front end. Finally, the front end from ScaffoldETH. Because everything we did so far, it is around the front end, but not the front end itself. Okay. Then I'm going to keep my blockchain running here at the left pane, and I have run this yarn start in the right pane. And as you can see, it is using NextJS. It is using the latest version of NextJS here for building this front-end application in localhost, in localhost 3000. That's the default port. Okay. Whenever I access this, it is going to compile. So this step here of compiling is writing all of this HTML for us. Remember that we said that we are going to outsource this job of building the HTML, CSS, and JavaScript for us. So this compiler step is speaking all of the instructions that were given for the framework, and it's going to compile, it's going to bundle all of the needed files for us to access this application in the browser. And here we have, this is what happens when you access your localhost 3000. This is the initial version of ScaffoldETH. If you run this command there, you should have access to the same frontend. Actually, let me just disconnect here because I had that connected before. Sorry about this. Now it is auto connecting. Okay. If you load this page, you should not see the connected wallet. You should see it like this. But you're going to see a upper menu here with home and debug contracts. You're going to see these instructions. Welcome to Scaffold ETH2. Get started by editing this file. Edit this smart contract here. Then some links to the documentation. And at the bottom, you have this link for a block explorer. So it is a full dApp, a full starting point for anything that you might need for starting your dApp development. Okay, this is built by the Beetle Guild. Okay, great maintainer of that repository. They have open process. You can subscribe to Beetle Guild by completing some challenges in the Speedrun ETH that we're going to show today. Okay, so you can become a contributor of this project as well. These people, this gift that we have here is it is an open good, it's a community resource for the whole Ethereum ecosystem, for the whole blockchain ecosystem, actually. So be a little entitled to it, a little piece of it, be part of it, okay, contribute to it. That is my call today. And this is a working the app on itself, like a showcase the app, where I can connect my wallet. Click here on connect wallet, for example, and you're going to see all of those options. So for example, I could connect my MetaMask wallet, connect to wallet, connect Coinbase wallet, Ledger wallet, Rainbow wallet, and we have here set up in this project a very special kind of wallet that is a burner wallet that is great for development. Okay, this burner wallet shouldn't be used for anything related to production or testnets or whatever, but it's a way that you can easily create new wallets, temporary wallets that are going to be in the correct version, correct nodes, correct metadata for these blockchains, test blockchains that you're using. And for example, you could pick money from a faucet by clicking this little button here using this burner wallet. You click 1, 2, 3 times, you're going to have money in this wallet inside this test environment. Okay, but the next time you open this application, the next time you host this application, for example, you could start with a brand new wallet without any funds and all. Okay, so what is the, you might be asking, what is the upper side of that, of losing my money every time I create a new wallet now? Because also you don't mess with your wallet configurations. Like if you have your MetaMask connected to your local host, you would need to always reset your wallet nodes and configurations for every new test. The burner wallet you do that for you automatically. Okay, so you don't need to worry with that. So it is a good feature. This burner wallet is a random new wallet, so it is different from all of those uh, pre-funded accounts here. Okay, so this is why you need to ask money from the faucet. And look here in the terminal, we have these transactions of money being sent for this burner wallet here. These faucet transactions happening in the console here. Okay. Instead of going to the console to see everything that is happening in your local blockchain, you have this button here at the bottom that is the block explorer that can also give you the same view of your local blockchain. These people is like, it's great to have. I don't know if you had the experience on developing things in your local host environment, but oh boy, how this is helpful. Trust me, I wish I had that for like hundreds of projects that I did in the past. Okay, as being able to see block by block what is happening in my local environment. Things that, for example, in the ages of Truffle and Ganache, I would have this visualization for my local blockchain. But if I want to do that for like automated tests and debugging contracts and all, it was very difficult to do in the past. Now we have all of this in a single place here. I can see my contract creation transaction back there in the first block. This was the transaction from that pre-funded account. And now I have a lot of faucet transactions sending money for this burner wallet that I have. Okay. If I connect here, let me disconnect my burner wallet and let me connect my MetaMask, for example, to this local network, local hard hat network. And I click grab funds from the faucet. These people is my account connected with MetaMask here. Okay, my MetaMask account. Let me connect my account number 1. So I have this account number 1, 0x99342. I can grab funds from the faucet here. And now my MetaMask account have this 2 ETH. Okay. My MetaMask account have those 2 ETH. And now let me show you how to bridge those 2 ETH to mainnet. Okay. That would be the best pro move. Now I can start farming money on mainnet. That's not possible, you see. Even though I'm using MetaMask here, even though I'm connected with the same account that I can sign transactions in testnet and in mainnet, I cannot port this money there. Okay, those are separate networks, of course. So you can use a MetaMask for the local network. You can mint money for it, a request for the faucet, but it's not advisable, because if you do something wrong, if you leak your keys, if you sign a bad transaction here in a testnet or a local environment, if somehow people have access to this, someone listening to your network, or if you publish this somehow, the private key that you use in your MetaMask for mainnet is the same that you are using for testnet and local environments. Okay, so it's dangerous. Always create new wallets for development. Okay, even if you follow the best practice and all, it's always good to create new wallets so you don't happen to mess up, so you don't happen to leak your private key, leak a bad signature, and have your funds drowned from you, okay, robbed from you. So this is why I even suggest that we use a burner wallet in these local chains, and we can interact with it. It has pretty much balance for it, okay? Good, so this is the block explorer. You can find it down in the bottom. Back in the home, we have all the suggestions of other things to do. Another very cool feature, even before we started the front-end development part, a very useful feature from ScaffoldETH out of the box is this debug contracts. Okay, this page that is going to detect all of the contracts that you have compiled and deployed inside the same tool, and you can interact with these contracts. Okay, before I click in those buttons, before I interact with this page, let me show you the structure, what is happening here on the ScaffoldETH. To recapitulate, we are at this point. I just hit here yarn start. I'm showing around ScaffoldETH before we go for this part. Okay, so let me show some of this structure of it. I'm going to open this ScaffoldETH folder in VS Code here. You can use your favorite IDE if you want. And this is the structure. Every Node.js, every JavaScript-based project that is meant to be run with Node.js is going to have this package.json at the root. Okay. Open there in your IDE, in VS Code preferably, and you're going to see that in the root of this folder that we download, we have this package.json that specifies a lot of scripts that we can run. Okay, this was coded. This was defined by the maintainers of this package, of the maintainers of ScaffoldETH. And for example, when we run yarn chain like we did, it's going to use yarn workspace, a tool from yarn, to run the package hard command chain. What is that? Here we have this folder called packages, you see? The last folder in this list. In this package, we have two folders, hard and NextJS. Hard for building the smart contract scripts and their on-chain operations. Is going to be some sort of a backend like for this project. And the NextJS that is going to have the front-end parts that we're going to see later. Inside hard package, we also have a package.json. So yes, a package inside another package. This is the structure of a workspace, a monorepo with everything inside. We have a chain command here. So look, this package.json is using hard package chain command to run the chain that is going to build a hard hat node on this network, local network, as we have configured here in this tool called hard hat. Okay. And if you don't know what hard hat is, you can see the documentation of it, hard hat docs. I guess I have it ready. Hard Hat is a blockchain development environment for Ethereum or anything EVM compatible that can give you a lot of tools like compiling smart contracts, running tests, running scripts, using linkers, running local chains, and all. A Swiss knife of smart contract development that uses JavaScript and TypeScript. Okay, so you have a lot of others. For example, one that is very common is Foundry that uses Solidity. You need to code the things in Solidity for running the tests and some scripts. Hard Hat, for example, you can code the things in TypeScript. The advantage here for us is that the frontend that we're going to code also uses TypeScript. So the things that we can code in the scripts for Hard Hat can be easily ported for running these same operations inside Scaffold ETH or inside the frontend as well. Okay. In my longer bootcamps, usually I do a few weeks of these bootcamps, I even show how to build tests and scripts in TypeScript in Hard Hat before we even go for the frontend. So later you can just copy and paste from one place to the other. For today we have a reduced time. Let's cut to the chase for the frontend. But this is a great addition, a great suggestion if you want to get more acquainted with Hard Hat and building scripts and tests before going for the frontend part. Okay. So this first thing that I'm showing is that when you download ScaffoldETH, you have this package.json with those scripts. One of those scripts is the chain that is using the Hard Hat sub package to run this chain command and running this node for you. Okay. For example, I could have test as well. Where I have test that is using Hard Hat test this command here, or for Hard Hat to test all of the features that I want. Okay. It's one package running the other, one package running the other. The other example that I have, that is the start. Look, I'm using NextJS to start a development version of the server. Okay, I would need to open the Next.js folder, the package.json, and we have this dev command here. So it is the same thing. My ScaffoldETH package.json is linking a command here for Next.js. So it's like a coordinator, puppet master, pulling the strings needed from each of those packages and combining them. Okay. This is one of the values that ScaffoldETH gives for you. It coordinates the Hard Hat project with the front-end project. Sometimes when you want to do this manually by yourself, you can commit mistakes. You need to understand this structure. You need to wrap your head on understanding where is the artifact, or how to pick this type and cast it to that thing that I need to use that. So instead of teaching this all in this short bootcamp, I'm going to show this tool that abstracts all of this away from you. Okay. Does it mean that you shouldn't study that? Should skip this part? Not at all, people. Because the tool do this for you, you might skip studying this part, but it's always good to look under the hood and understand what it's doing for you. Of course, you don't need to do that inside a hackathon. You have a deadline to meet for submitting a project, for building this the app and all. But before pushing to production, for example, or before going serious with a production project, if you haven't yet, it's good to understand this link, this correlation between the artifacts that are built in Hard Hat, what were important for Next and all. Because the same way that Scaffold it can help you, it can also rob you of understanding this. So after, when you have time, due time, study the things that Scaffold ETH is doing under the hood. Even because you might want to become a contributor for that, right? So a lot of good reasons for this. This orchestration here between Hard Hat and Next.js is all solved by those scripts. When you are running yarn chain, yarn deploy, yarn start, everything is set up for you here beautifully, neatly. Another thing that this this project is set up, this structure is set up to do is installing all of the dependencies, okay? Instead of you manually installing all of these little files, little packages, for example, look at the dependencies of the front end. You have all of those. Imagine you installing 50 or some programs inside your computer. How long it would take? And all of those programs would install all the dependencies of themselves as well. You would spend weeks just installing and then later uninstalling these when you need. This is why we use those package managers. So you might be wondering, hey, why we are using R and why you are using these things? Because it's going to build this huge node models folder, and huge because it usually has a lot of megabytes, gigabytes sometimes, with all of the dependencies for your project to run. Okay, inside this folder, node models. So these programs, libraries, and all, they are not going to clutter your environment, your device. You can simply delete later this node model or this folder, and everything is going to go away. You don't need to go manually on installing it now. And it also manages those versions for you. Remember, I was mentioning that version compatibility thing at the beginning of the lesson. So these package managers, they manage version 8 dot something of this package with the version 5 of all of those other packages. They manage this for you, so you don't need to handle any of that. The experience suggested is that you run the commands and you have your front end ready for you to run. Okay, so this is the idea of this package.json setup. This is what the package manager is going to read and orchestrate those scripts and those dependencies for you. Okay. Second, inside those packages, we have those folders. In the front end, we're going to see a lot on the app and components part. In the hard hat, we are going to see a lot in the contracts and the deploy folders. Okay. In the contracts, remember when we were using Remix, we had this contract folder with those templates, with the storage.sol, and then we created frogjump.sol, then payfrog.jump. This is the same idea. We are going to have a contract folder, and here we have this template called yourcontract.sol. Okay, that is a Solidity contract. As you can see, it has everything that we saw in the structure of a Solidity file on Saturday. We have this contract named your contract. And here we have some state variables. We have some events, a constructor, a modifier, a function. It is a good sampler of many of the features of Solidity language. Okay, many of those features we haven't studied yet, but you can find all of them in the documentations that I have shown on Saturday. The good part of ScaffoldETH is that instead of clicking in those little blue boxes of Remix and interacting with it just with the interface, with hard hat environment, you can do that. You can create TypeScript scripts like this script 0 deploy your contract that can interact programmatically with your smart contract. Given that you know a bit of the TypeScript programming language, and given that you know the basics of those tools, for example, hard hat, we can develop these kind of scripts. For example, this deploy your contract.ts is a script tasked with one single thing. It is going to deploy a smart contract to the chain, and then it is going to call this contract for getting this function called greeting, like we have here, through TypeScript, using something called hard hat runtime environment for creating this link, for creating that connection. Okay, so imagine you have a smart contract that needs some initial setup. You need to pass a list of whitelisted address for you to airdrop. You need to set up your I don't know, like contract managers. You need to set up your roles. You need to send a lot of transactions in the beginning of your smart contract life for configuring it. Okay. Or you want, for example, you're creating an NFT connection and you want to meet some NFTs to put there as a sample, for example. Instead of doing that all manually, you could build a script and test that in your testnet to see if everything is working correctly. And then you have the same script running on mainnet later because you tested that before to see if it was working. Okay, this all is possible with these scripts, so you don't need to manually do all of that yourself. Okay, and the good part is that when we run the deploy command, when we compile here, deploy automatically, ScaffoldETH can create this page, this debug page, that you have this some sort of interface, proto interface for interacting with your smart contract. Here in the left pane, you have a list of contracts. In this situation, you just have your contract here with this address deployed in local hard hat network, where we have a value for a greeting that is stored there, a value for an owner, a value for a premium, and a value of total counter. You are going to see these variables defined here inside your contract.sol, those state variables. Okay. Remember from the last lesson, because they are market public, they get a setter. A getter. They don't get a setter. They automatically receives a getter function when we compile that smart contract, and then we can call these. Then we can call these members. Okay. So, for example, we have this function here to write a greeting using this account 572E from this burner wallet. We can call this set greetings function. That is going to invoke this function here, set greeting, that requires a string in memory. Remember that we saw that this is a thing about strings. Do you remember why we need to put memory data location? It's because for solidity, for the EVM, strings are an array, a special kind of array, remember? So we had something very similar in our past smart contract that we're going to do this. We're going to pass this greeting here, and it is going to set these variables so that later when we get the greeting from the smart contract, it should be equal to this new greeting that I'm passing. Let's see if that's the thing. So for example, hello pond instead of hello world. Okay. And I'm going to send this transaction. It was very quick. I can see here in the block explorer that we had this transaction for the function set greetings called from my burner wallet address to this smart contract address. This transaction here happened a while ago. I can even see the details, the data that was passed. Okay, this data that was passed was a string with the content hello pond, and here when I see the greetings, I have hello pond here displayed. If I put the new greetings like croak, send, here we have these new greetings and a total counter of 2 greetings sent for that smart contract. Okay. This is what is happening in that smart contract here. Everything that happens in this Solidity, you can now easily and quickly see happening. The repercussions of it, we can see it happening in the front end in that debug function. Okay, so it's even good for learning Solidity. Instead of just using Remix and the limited interfaces, we can do that with scripts, and we can use this debug page from ScaffoldETH. Okay. A quick challenge, quick trivia. We have this premium here set to false. This premium variable is a boolean defined at line 19 at this contract named your contract. And a boolean can only have two values. It can be either false and true or true. And we have a mechanic here that whenever the message value is higher than 0, we saw that on Saturday, whenever the MSG value is higher than 0, I'm going to set the premium as true. If the MSG value is 0, premium is false. Every message that we have sent so far here, we use it with a MSG value as 0. How would I do to send one ETH for that smart contract for it to set the premium as true? What would be the value in way? Do you see here that we have this field for putting a value when sending this transaction? How would I pass one ETH for it to set the premium equal to true? If you know the answer, you can type here in the chat. Let me see, 0.9. Okay, this is a thing. Good suggestion there, Daniel. In the pay frog jump that we did in Saturday, we had a minimum price of 1 ETH. In this situation, we are expecting the MSG value to be higher than 1, to be higher than 0, right? So for example, 1 ETH. So let's try with that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros. That is going to send 1 ETH to the smart contract, right? Now we have the premium equal to true. The greeting is still croak, I forgot to change, but the premium is now true because the MSG value is higher than 0. We have sent 1 ETH to it, right? You can see the transaction received here. So we have sent a value, where it is, should be here somewhere. Value. It's not in the transaction recipients, but it should be in the block explorer. Okay, we set the value of 1 ETH. Correct. That is an easier way for us to do that when sending, for example, take my money. I can put 1 here, just 1, and we can click in this asterisk here to multiply by 10 to the power of 18. This is a quick feature of the component input programmed by ScaffoldETH. So you can do these multiplications here. For example, I want to send 2 ETH. I can do this multiplication here. Okay. If you don't have enough ETH in your account, Daniel, make sure to click here in this faucet button so you can request. For example, let me try and send 3 ETH here. Okay. Now, if I try to send again, like I'm poor, it's going to give an error. I don't have enough funds. Okay. I would need to add those funds. But people, if like, let me go back to 0 value. I'm going to send I'm poor, and then the greeting is I'm poor, and then the premium is false. Okay, because I haven't sent any value. Do I really need to send 1 ETH for the MSG value to be higher than 0? What would be the cheapest way to make the premium equal to true here? MSG value is accounted in way units. So I don't need to send a whole ETH here. I could send just one way, and then I can say I'm poor, but I'm premium. And then I can send this one way, and premium became true, you see? So the only thing that is being checked in this smart contract here is whether the MSG value in way is higher than 0. So even if I send one way, premium is going to be equal to true. Okay. Another good way for us to understand those maths here. Okay. We have this. We have this simple check that we have here. Okay. Good. So this is the features from ScaffoldETH out of the box. Okay, we can run a local chain. We can deploy contract switch. We can run scripts on it to deploy those contracts. We can use the debugger. We can use the block explorer, a full set by itself. So you can use it as a tool. But we are going to pass forward than that. We are going to use it for developing a dApp. We are going to start and customizing with these contracts and with these pages here. We can edit this page. We can edit those smart contracts and see that ScaffoldETH is going to automatically read our smart contract, is going to automatically provide us connections and tools and means for us to scale up all the app development. Things that would require a few hours, sometimes a few days to do, we can quickly complete these with just a few minutes using ScaffoldETH 2. Okay. Let me show step by step how it's done. We're going to pick from this part, okay, using ScaffoldETH 2 for the app development, and we're going to do this first step. If you didn't participate in Saturday's lesson, you are going to see the code for frogjump.sol up here, okay? Just scroll up a bit, and you are going to see this content that we make this simple counter. We just dressed it as the frog jump contract to be in the frog theme, that whenever I click on the jump function, is going to increase the number of jumps. And I have this constructor receiving a name. So each of those frogs, they're going to have a name as well. And later we did another version with pay frog jump that instead of having a fixed jump function that is just going to jump by one every time we click on it, every time we call it, here the amount of jumps is going to be a variable that is going to be used when calculating the message value, the amount of value sent for that contract, okay, for that function calling that contract. Not the amount paid by gas in the transaction, the amount sent for that function in the contract, okay? So I suggest that we copy this smart contract and we put it inside a file called frogjump.sol, okay? Inside package hat contracts, you're going to create a new file named frogjump.sol, and you're going to put all of the contents from it. Another way, if you want to use ScaffoldETH without editing the deploy functions too much, without editing the structure, you could even start editing the your contract.sol, okay? But I want to introduce the idea of the script of the deployment, so I would suggest that you create a new file called frogjump.sol, okay? And that you put the code that you want specifically here. And we're not going to change your contract.sol. Okay, we're not going to change the contract that was there. And we are going to put this code for the frog jump. Okay, I'm going to put this code there. You can put the hey frog jump if you want. I just need one of these for showcase. Okay, this contract called frog jump. If I put it there in the contracts, when I compile with hard hat, it's going to be auto-compiled, but it is not going to be automatically deployed. Okay. Let me open another tab in my terminal. Let me split view now. Top, bottom. 3 tabs. Keep track of it. Okay. Left tab here. I have I didn't create a new tab. Sorry, it's split. So in the left split here, in the left section, we have the blockchain running. In the right topmost section, we have the front end running. Now in the bottom part, in the right bottom part, I'm going to run the deploy, yarn deploy. I'm going to run the deploy task here, okay? Just by putting the smart contract in the folder, it doesn't make it deploy the new smart contract that I want, okay? We have this thing as well. I'm going to fix that because it's an error about compilation. But just by putting the smart contract there in the folder frogjump.sol, it does not mean that it's going to be deployed, okay, by itself. It is going to be compiled. It is going to run whenever we want, where it is, whenever we want to compile the smart contracts, we can do this command that is going to be invoked before deployment. But it's not going to deploy this smart contract by default unless we create a script for that, okay? Now let's solve this error because the project cannot be compiled because it requires the version 0.8.90, okay? I have a suggestion here in the README on how to solve that. It's because you need to open your hardhat.config inside the package.hardhat, and then you change the compiler configuration for version, Solidity compiler configuration for version, to 0.8.90, okay? The line 24. And then it's going to work. Let me show that for you. Here inside the package hardhat, you are going to find this file called hardhat.config.ts, okay? It is not going to be in the root of ScaffoldETH, no. You need to open packages and hardhat. Inside this folder here, hardhat, you are going to find in the root of this folder hardhat, this hardhat.config.ts that has a lot of configurations for how hardhat is going to work, how the local network, how the environment configurations for hardhat, how it's going to work. In line 24, we have this version 0.8.17, okay? That is good for us as well. If you want to keep this version, you could pick frog jump and put 17. It works as well. Or if you want to put the hardhat in the same version that we use it, you could pick here line 24 and change from 8.17 to 8.19. 0.8.19, okay, line 24. And when you do that, you can run the compile, yarn compile, for example, and you can also run yarn deploy. Now it's going to work without giving this error, okay? So look, it compiled the smart contracts, compiled your contract, compiled the frog jump, but it did not deploy frog jump. Okay, it just deployed your contract here, deploying your contract. If we look at the block explorer, we are going to see that it deployed only one contract here in the block number 17, you see? Sorry about this. It just deployed one smart contract here in the number 17. If that's too confusing for you, too many blocks, too many things happening, a quick way to solve that is just to stop your blockchain, stop your panel, your tab or whatever running the blockchain, and then do yarn chain again. That's going to spin up the blockchain environment again. And then you reload your page. So now you have everything cleared up from scratch. And if you run the yarn deploy again, you are going to see just the transactions pertaining to it. Look, I have just one transaction now, one contract being deployed. Okay. So what I'm trying to prove here, this can spark confusion sometimes. What I'm trying to prove here is that just putting the smart contract in the contract folders, it does not create a deployment script for it automatically. No, you need to code this yourself, okay? And I'm going to show how to code this. Okay, let me stop my chain again and restart, just for us to have a clear state. So if I reload here, it is empty. Let's go back for the README and let's do the step number 2. We are going to create a deployment script for your contract. Let's create a new file named 01deployfrog.ts in that deployments folder. So open this folder there on your side, package hard deploy, packages hard deploy, and you create a new script file here, 01deployfrog.ts. And anything you code here, people say, oh, TypeScript is too complex. I need now to understand how automated deployment works and all. No, people, this is just a script. Anything you put here is going to be executed ipsis lipsis, as you put. So anything, actually anything you need to know here is the syntax for each command, for each tool that you want to invoke. Okay. For example, let me prove that this is a simple script. Let me do console log hello. I'm just a simple script. Console log hello, I'm just a simple script. And if I run this command now on yarn deploy, it's going to pick all of those scripts there. It failed. See. Okay, I did not export. Yeah, I need to export something. That is true for it to work. So it's not that of a simple of a script. Forgot that little step. But when we are executing this script, you are going to see that all of the syntax that we put here, this function, deploy function that we are going to declare in a while, line 22, 23, 25, 26, and all of that, they are all going to complete the tasks that we want, that we code ourselves. Here it is using the hard runtime environment to get named accounts and do other things, but I could code it in other way. Okay. So the suggestion, I'm going to return to that. Okay, don't worry. The suggestion that I put here in this README is that we have this deploy function. Okay, I suggest that we do this deploy function. So you can copy everything that you have in your deploy your contracts.ts. You can copy everything, copy the whole file and paste here deploy frog. Okay. But we are going to replace the deploy function, this deploy your contract function. We are going to replace everything by this chunk of code here, deploy frog jump. So instead of having this deploy your contract, we're going to replace all of this, can remove everything, and we're going to replace it as deploy frog jump. Okay, forgot this. Okay, we're going to replace from line 40 to line 5, from line 5 to line 40 actually, up to down. You're going to select from line 5 to line 40, and you're going to replace it all for deploy frog jump. That is going to be the function of deployment that we want in this script now. Okay. So instead of having this your contract being deployed, we are replacing it for a version that has frog jump being deployed. Okay. And then we don't need this tag part. You can delete these bottom lines. I don't need this ethers path here. I'm not going to use this contract. You just need those lines here for it to work for you. Okay. And now let's go back because I needed that function to be exported. Let's go back to the console log. You don't need to do that on your side, but I'm going to comment all of these lines. And then I'm going to do this console log. Let me console log. Hey, I'm just a normal script. Anything you put here is going to run as you code. But here is going to run as you code. Okay, let me run this deployment function now. Now it's going to invoke that chunk of code. Okay, so here is the first script, your contract. Okay, this is the deploy script 0 that we have here running. After we run this deploy script 0, we have this other deploy script 1. Hey, I'm just a normal script. Anything you put here is going to run as you code it. So as you get more acquainted with Hard Hat, as you get more used to the tools that we are using here, not in today's lesson, unfortunately, but what is the HRE? What's that? The Holy Roman Empire? No, it is the Hard Hat runtime environment that we are importing so that we can pick a deployment to deploy this contract named Frog Jump from the deployer account with the arguments of Froggy, and we're going to log through, we're going to automine through, and then when we have this deployment like this, it is going to be included in the chain. So this is not some magic piece of script that it's too difficult to understand. It is speaking some specific functions of Hard Hat, some specific APIs that you can call inside this library to pick the local network you have configured here in the Hard Hat config.ts, this local network, and then you can run this deployment. Okay. And the good part of using it like this, that later, when we want to deploy to a testnet environment or even to the mainnet, we just need to change a little parameter that is the network target. And everything is going to work exactly equal. The things that are working in testnet should work in mainnet. The front end that is working in testnet should work in mainnet. The front end that is working in your local host should work perfectly when you deploy it, the testnet in mainnet, because you're keeping the same structure, the same configurations. Okay. So imagine if this is a hackathon project If you are building the things all in testnet or all in your local host, you don't need to expend extra time to make it work in a public testnet later or in the mainnet, because it's just a simple configuration. You set up your account or you fund it with gas, it should work exactly the same. So that's the idea of this framework of behaving like this, of using the hard hat runtime environment deployments for doing that, is to guaranteeing this conformity. Okay. Now that we have finished the step number 2, created the deployment script for your contract, and we did this step number 3 before, I'm going to run this step number 4 to deploy the frog jump contract and interact with it in the front end. Okay. For it to be easier to see, I'm going to restart my blockchain again. Okay. I'm going to do yarn chain from scratch again. You don't need to restart your front end. Okay, the front end part is good. You can hot reload and all as needed. And here in my bottom right pane, I'm going to do the yarn deploy. And pay attention. We're going to run the deployment of your contract here and the deployment of frog jump in sequence, one after the other. If you go now for your block explorer, you are going to see both of these. At the block number 1, we have the deployment of this contract, that is your contract, template contract for Scaffold ETH. And in the block number 3, because we minded an empty block in the middle, it was programmed there in the script. In the block number 3, we have this deployment of this smart contract. These bytecodes are the same bytecodes that we deployed using Remix for creating that frog jump. Okay, let me grab some funds from the faucet twice, and here I have those transactions here. Okay, now you have your new contract being deployed. If that was a token, for example, you would deploy this token and mint the amount you want to mint, give the roles that you want to give. If that was set up the bets or whatever, if that was a NFT, you would deploy the NFT and do the pre-mint of the tokens or set up URI and all. You could code all of this sequence here inside the script. You could even test this in hard first in a testing environment, creating a test script here. For example, you have a sample test for your contract.ts. It should behave like this, it should behave like that. So imagine you are doing an NFT project. You can create those test cases that you can go there and run like yarn test. For example, it's going to print out in console if everything is working correctly. Your contract, you have 2 tests passing because you should have the right message on deploy and should allow setting a new message. So you could write those tests in TypeScript for everything you want to do inside your contract. I should set greetings, should do this, should behave like that. In your NFT contract, in your token contract, should behave like this. You have specific rules and now. And then when you want to create your scripts, you can just copy the things that are working the tests and put here in your deployment script. And even better, later on when we see that working in the pages, when we see those components calling those functions, it's going to be TypeScript again. So first you do the test, you know the test is working, the TypeScript is working. Then you do the scripts, you use the TypeScript functions in practice for calling those functions, those operations in your smart contract. And then when you want to make it usable by your end user, you use the same TypeScript samples, okay? So you already know that they are working properly. You did a test file for that. You already used them in the deployment script for calling some functions. And now you can use the same code out there in the front end or in a back end to using TypeScript, all inside the same stack. Okay. So for a beginner, before you learn like Go, Rust, Python, a lot of things that are needed, even Solidity. Let's say you are using Foundry for writing tests in Solidity. Even before you are a professional with Solidity, even before you understand the full scope of Solidity, you can use TypeScript as a provisory mean as a starting point if you already know JavaScript and TypeScript for interacting with smart contracts for building a app before you acquire the needed knowledge that could take a good 6 months, 1 year for you to get there, or 3 months, depending the time you have for dedicating yourself. Okay. It's great if you have experience like with front-end development. You can start using more and more of TypeScript for doing the smart contracts part itself. You still need to learn Solidity. You still need to learn the whole things. But again, if you are in a hackathon, if you have a limited time for getting started, this can be a quick start. This can speed run your way to Ethereum before grinding to all of the needed material, right? So this is the idea here of this deployment script. And the rewards that we get when we do this way, we put the contract inside the contracts. We do this deployment script. The reward that we get is that now we can go for the debug contracts page, and without coding a single line of front end, we now have a first version of Frog Jump here. We were using your contract. You see here, there is this spill here, your contract. We were using here for changing these greetings and all. Remember? Now you can go for Frog Jump, and you have this crude interface, this simple interface that anyone can connect the wallet and see that we have a name, 0 jumps, and I can start sending jumps operation here to see that this frog has jumped 5 times. Make it jump a lot of times. Let's see how fast this front end can go. Let's see if I can make it 60 very quickly. See, it handles too many transactions. Okay, here we have 60 frogs in under, I think 60 jumps for that frog in under a minute. Okay. If we look at the block explorer, we're going to have a now full lot of blocks just for that. Each transaction is being put inside a block here because of the way that this local network happens. Okay, this local network works. And you can see all of that behaving, interacting here with this front end, okay, using this burner wallet. Looking good? I know that this is not a structured page yet. This is not, you don't have a UI, you don't have the frog jumping, you don't have the actions here, the button is widened out, you don't have read methods here. I know. It is still somewhat limited, but it's a starting point. If this is a hackathon project and you don't have time to develop the front end functions of it, this is enough for you, for example, to demonstrate your contract inside the front end. Okay, instead of doing that in Remix, this is something better for you to present. Okay, it's not a perfect state for you to present, but it's better. How long did it take us? Let's skip the 1 hour of introduction. It took us 50 minutes to get here, explaining bit by bit, even a newcomer, even if you came from design, even if you came from law, even if you came from any kind of backgrounds, you would still be able to shape this front end in less than 1 hour for your hackathon project, picking a contract that you built on OpenZeppelin Wizard or something, and this could be a valid submission. Okay, you can say that you started contributing for blockchain. You can already say that you started your Web3 journey, front end development part of your Web3 journey. Okay, but we're not going to stop here. We have 1 more hour, okay, for completing our next challenge. But this can get you started with this tool. This can already put you on your tracks for the app development. Okay. Don't know if you have questions. Let me check the issues as well. Whenever you have issues, if you're watching this in the future, whenever you have issues, you can open a new issue here on this repository, pick the line that you didn't understand or the line that didn't work for you. You can open issues here and people can collaborate. I can pick those questions later on as well if you want to have some asynchronous help. Okay. So we stop it here at this point, deployed, and now we interact with it in the debugger page. We made this frog jump 60 times, okay, and have our scaffold ETH working. Next part, in the next hour or so, I'm going to guide you through this challenge number 0 of Speedrun Ethereum, okay. This Speedrun Ethereum is a great resource. It's a great resource for us to get started with blockchain development, developing dApps, not just the smart contract part, but developing dApps using Scaffold ETH. Okay, you have a great quick video from Austin himself, creator maintainer uh, of the build guild of Scaffold ETH. He created the version 1 of Scaffold ETH. Austin Griffith is one of the best teachers that I know out there. I learned from him back in 2019, his first videos. And it's a 30-minute getting started intro video for Scaffold ETH. I really recommend. Okay, I'm going to try and do an explanation of getting started for this lesson, for this challenge 0 that we're going to do as well, using Scaffold ETH 2 that I just showcased you, this version 2 improved version of this repository. So the idea of this number of challenges, this sequence that you can go through here, is that once you finish those 3 first challenges, you can like connected on chain with your MetaMask wallet here for submissions and all. You can pledge to join the Build Guild, where you can, for example, start streaming ETH. You can start opening grants. You can start participating in community events. You can start, for example, asking resources, asking maintainers how to solve your bugs, how to implement your contract. I'm part of the guild, a rookie member of the guild myself. I can try and help and contribute for all of the kind of projects that we have. And they also have this broad horizontal approach, holistic approach of welcoming everything inside the Ethereum ecosystem and Linea inside the ecosystem, the Ethereum ecosystem. Like Emily knows Austin for a long time as well. We are co-marketing out and offer this mini bootcamp, reaching more and more people. We can have this support for building on Linea as well. For example, anyone can come here, complete these challenges, use that for beginning your hackathon project, become part of Build Guild or have people from Build Guild to help you, for you to ship the things that you want inside Linea. Okay, so one of the things that we are going to do today is use a slightly different, a slightly adapted version of this challenge 0 using this metadata. What I have here, this metadata inside this repository, this NFT metadata that have those e-frogs, okay, this Linea collection that sets a great theme for this bootcamp, the e-frogs. And we are going to, for educational purposes, we're going to use these NFTs images as a settings for this lesson. Instead of running the normal challenge number 0 quest that we're going to follow here that uses these images as default. Later, we are going to change this for using the frogs and make this bootcamp, this challenge 0, even more froggy in the Linea spirit. Okay. so we can make ScaffoldETH go croak here in this lesson 0. That's the idea. That is Speedrun Ethereum. I hope you all give a look on that later, a better look what it has to offer, what the Beetle Guild has to offer. And now for the next 55 minutes or 60 minutes, I'm going to guide you through this challenge number 0. At the end, I hope that everyone can, with a wallet connect, you can go here and submit this challenge with the deploy URL and deploy to some URL, probably to Linea here, but we could deploy to Sepolia the same way later. Okay, and we learn how to build this app. Okay. So instead of just using this debug context that we have here, we are going to edit the things contained here inside the NextJS applications folder. Okay. But instead of, sorry, split some water here. Instead of coding this ourselves, editing this scaffold and coding bits by bits and pieces of it, we're going to follow this example from challenge 0. We are going to follow from this version, this setup version that you can download, that has all of the files in place. Okay, all of the front-end configurations in place already. So we don't need to code the front-end ourselves. We're just going to look under the hood later. Okay. So pay attention here. I'm going to close this localhost version. I'm going to stop my chain. I'm going to stop my front end. I can even close those tabs actually, because imagine we are starting from scratch. Everything that I did so far in those 2 hours were to introduce you to the tools. Okay. Now we go real. We go heads. We jump heads in the pond. That's what I'm trying to say. We start to put those tools in practice. Okay, so I'm going to exit this Scaffold ETH2. Pick a new folder. If this is, imagine if this was your hackathon project, you would pick Scaffold ETH2, you would create a fork, and you would start editing it for being your project here. Okay, I'm going to create a new folder so that now we're going to do this challenge 0. Okay, and if you want to keep doing the other challenge, you would do the challenge 1, 2, and so forward in different folders. Okay, but if that was your hackathon project or your project that you are trying to develop, you want to send that you would keep inside the Scaffold ETH2, and you would create a fork. You would move that for a different GitHub repository, and you would edit from there. Okay, hope that this is clear. We are going to do that in a new folder so that we can follow these steps. We're going to clone this Scaffold ETH2 challenge git on the folder challenge 0. Okay, you are going to see all of these challenges in this repository. Okay, you're going to see all of the challenges here, challenge 0, 1, 2. After the second, you are eligible to join the Beetle Guild. There are many other challenges. If you complete all of these challenges, you can consider yourself quite ready for any professional project out there, hackathon project, or being hired or so. It's a great resource for you to get started with blockchain. And we are going to clone this challenge 0. Okay, this is going to create a new folder for us in your computer with that, running this command. Okay. Oops, here. So just to make sure that you understood, I exited the Scaffold ETH2. I'm going to clone inside this folder challenge 0 simple NFT this repository, Scaffold ETH2 challenge git. I'm going to enter, oops, sorry. I'm going to see the repository was cloned there. Oops, here, there, challenge 0 simple NFT, and I'm going to enter that. If I list the files here, I just have the README that is intended, because the way they have organized this repository is that you're going to have a branch, 12 branches here. You're going to have a branch for each of those challenges here, okay? The 0, 1, 2, 3, 4, 5, 6, those 7 challenges, and you can check out, you can clone from them differently, depending on what you want to do inside the same, sorry about this, inside the same structure, okay? So to select what you want to clone, you would do this command. I would git checkout. Checkout is going to pick a branch that I'm going to be connected to and download the code pertaining to just that branch. So before checkout, I just have this README, you see? After that, I'm going to have all the content from this branch. The packages folder, the package.json that we saw. This is a full ScaffoldETH project configured already for that challenge. Okay, let me close my VS Code here. Let me open my VS Code in this new folder. Okay, so it looks very similar. I have this package.json, very similar to what we had before. I have these two packages, Hardhat and NextJS. And inside Hardhat, now I have this contract called yourcollectible.sol. That is using ERC20, ERC20, no, it's using ERC721 from OpenZeppelin. Very, very similar to what we saw on Saturday, right? It is importing these classes from OpenZeppelin. OpenZeppelin is installed there as a dependency. It is creating your collectible, and we have this script here for deploy your contract that is deploying this your collectible here. Okay, see, for it to run, for it to execute, we need that node modules folder so that we have all the dependencies installed. So we are going to do that with this command. Let me follow the README. We are in this step number 2, following this simple NFT example. So let's follow this instruction. But now we're going to do this yarn install. It's going to flow the same way that we did in the past hour. Okay, people. Same thing that we did with ScaffoldETH, we're going to do here with this sample project. It's just that it has this contract, it has those pages and all in place so that we don't need to code them ourselves. After we have this installed, we're going to have this node models, and everything that we try to do now, deploy, the contracts, the compiler, now it should work. Okay, should be able to open these without errors now, with everything in place. And I'm going to go forward and split my view in 3 tabs already, just like we did a while ago. Me adjust the zoom here. I guess put it like that, like that. If it is still not readable, please let me know here. Clear, 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 and clear. So in the left pane, I'm going to do yarn chain to spin up this local chain. In the right pane, in the top, I'm going to do yarn start to start my front end, my Next.js application. And here in the bottom, I'm going to run my commands. For example, what is the command that I can run to deploy the things in my blockchain. Let me open my front end just to show that I have the same structure of Scaffold ETH now, but the pages were changed a bit. So this is taking a little while to compile. This is normal. We have a lot of pages there. Compiled in 15 seconds. And this is the same structure for Scaffold ETH, just not now we have some content placed there for us. If we go at the block explorer, we are going to see that we don't have any contract deployed at all. So what is the command that we run for pushing our contracts to the smart contracts that we have inside the hard folder to the blockchain again? If you remember well, is the yarn deploy. That is going to run those scripts that are inside the deploy folder. And here I have the folder, the contract your collectible deployed. It's not that your contract.sol anymore, you see. It's now programmed to deploy this your collectible. And if you access here your block explorer, you're going to see this transaction, this contract your collectible deployed there. Okay. The home page was replaced by this explanation, okay, that we are going to create a simple NFT contract to learn the basics of Scaffold ETH2. Okay, we can interact with the hard there as well. The hard part is a little more hidden. It is behind the scenes, but you can interact with it since it's a dev tooling, right? You can interact with the tests and with the scripts here. For example, this challenge 0.ts. You're going to see all of the tests here that should happen. The deploy script, as we said. So it is behind the scenes. It's here inside this hard folder. You can interact with it as well. But since we are learning the app development today, here's the front-end part that is interesting for us. Okay, and we are going to have this my NFT page. The next thing that we are going to test out after we do these steps is to interact with the my NFTs page. For that, we're going to need gas. We are going to need money in our wallet for paying the gas. So the first thing that they suggest in this challenge is that you go for the faucet, this little money button, you select your wallet, and then you grab your funds from this faucet. Okay, we did that a few times. Let me show here in the interface. We did that a few times. Every time you click on it, you're going to see it here in the block explorer. Okay, good. This is using a burner wallet. Okay, remember that we explained about those differences using MetaMask and all. So the burner wallet, it's a great fit here so that we don't need to handle this connection with the MetaMask. We are going to interact between our wallet and the other later on. So this handles it for us easily. Okay, you can see the faucet button here, just like they showed in the article. So you can ask money for different addresses as well, amount to send. So for example, instead of asking one by one, I can copy my address, put here in the faucet, and ask 100 ETH at once. Okay, and now I have 102 ETH. Oh, if that was that easy in mainnet, then the money would be all worthless, of course. Then we are going to head for this my NFTs now to continue the challenge. Just 1 second. Sorry about this. I guess I have something in my throat. Okay, we're going to head over, now that we have access to a good amount of ETH. Now I have what it is, 102 ETH. I can go for my NFTs and start rolling. Okay, people, if you ever mint it so much, you spend it so much gas that you don't have more gas for testing things, you can always restart your blockchain to the early stage, to where you have 1000 ETH again, and then you can do your operations all again. But that's very difficult to do unless you are doing something in loop or losing these funds in the process. But here we have 102 ETH, and we have 900 more available in the faucet, 898 actually. And then we are going to move forward for this page called My NFTs. Okay. Out of the box, this page is already coded so that when you click on Mint NFT, this is going to create a transaction, on-chain transaction for your local network. Here, it's going to appear here. It is going to create an on-chain transaction that is going to call the contract for minting a new NFT. And under the hood, this is going to upload the metadata for IPFS. It created this buffalo here with the metadata that we have, and is already fetching the attributes from that, the description, the owner, and it has an interface for me to transfer those NFTs around. This is this is the explanation here in the challenge. I'm going to click mint item. You can do this one time, two times, three times, and you're going to see all of those NFTs appearing for you. Okay, so one time, let me do 1, 2 more times. This is going to upload the metadata for IPFS. Okay, these integrations are already there. IPFS upload and IPFS download. These integrations are already in place for us. And these NFTs are all using the metadata hosted in IPFS. Okay. If you don't know the IPFS, it is a decentralized way to store files, not like a blockchain where you have 100% consensus of everything. It's more like a decentralized network, like torrents or something. It's very different, but you can understand it like this. It is the interplanetary file system. The name doesn't help it so much, but it's a decentralized way where we can store things. And now I have a buffalo, 2 zebras. I want another one here. The zebras that are repeated, I can send them for someone else. And now a fish. Okay. Inside the same network, I can open a new tab, a new incognito window. Here, let me put it on the side. And I can navigate to the same website. Okay. And then I can get a burner. Let me put this side by side. Okay. It's going to work better, I guess. Yes. Okay. Side by side. In the left here, I have this burner wallet connected to this address, 0x572E. And in the right pane, I have this incognito tab with this other address, okay, with this address 6EFF, okay. Let me ask some money from the faucet. See how better it is from using just MetaMask. Now, without worrying with enabling MetaMask in my incognito mode or whatever, I have this burner wallet, disposable wallet, that I can interact with it very quickly and dispose of it as quickly as well. And those two are connected to the blockchain. I could send money, I could interact with each other in that network, even without a smart contract. And what Speedrun Ethereum Challenge 0 asks us to do is that now we can transfer one of these NFTs for the address that we have in the wallet there. Okay, so for example, I can pick this address that I have in my incognito mode wallet, and I can come here to this NFT number 2 or this NFT number 3 that I have repeated, and I can transfer to this person, to this order address, clicking on send. This is an interface. All of this would be possible without using the front end. Let's remember that. But now I have less number of NFTs here in my wallet, this left pane wallet, and the NFT appeared there in the right pane. This was a blockchain transaction, people. Let me show that in the Explorer. I had this transaction of transfer happening. Look. Now I have it there. If I want to transfer another one, let me transfer this fish. Let's say I don't want anything fish related. Fish can be dangerous to frogs, right? I don't want anything with fish here. Let's keep our frogs safe. I have a bison and a zebra. Those are quite safe for frogs. Here I have fish and zebra in the other wallet. Okay, all of those transactions are happening on chain. Look here, I have those transactions happening on chain. These transfers and these mints and now. I could even try and mint one with the other wallet. Okay, now I have a flamingo, a beautiful one. Okay, so what is happening here? In this challenge, we have a pre-configured repository that is already able to provide visuals, provide interface clickable buttons and display of images, all of that pre-configured for us to showcase what you can do with ScaffoldETH. Okay, let's deploy this contract to Sepolia before we change for Linea, just to understand what those deployment features are. Okay, so we are going to do in Sepolia just to understand the tool that we do for real on Linea at the end of today's lesson. Okay, since we are using a local environment here, if we host that online, if I want to show this project for a friend, if I want to show this project for a friend, if I want to get early users for this project, if I want to show that for the judge of my hackathon project and all, I would need to host in my own computer and connect it to my local host and be online all of the time. It can be done if you are in limited time. But if you want to host that 24/7 for people to use it by themselves without calling you, without sending you a message before, without interacting with you, the best way to do that is to deploy to a public testnet. So we are not going to run this local environment anymore. I stop at my local environment. I stop at my local blockchain here. If I try to connect now with anything in the front end, if I try to go for the block explorer, if I try to view my NFTs and all, we are going to have these errors popping up. I don't have NFT. I can't request this. So this request has failed. This is a error display from Next.js. Okay. So this request has failed from this URL. Okay, failed to fetch. You see, this would be the experience that people would have if you host this without going for public testnet first. I want to solve that. I want to make sure that anyone can connect and experience with the app, even when my computer is offline, even when I'm not involved. So these are these next steps. Okay, you are going to open this file hardhat.config.ts package hardhat. You're going to open this hardhat.config.ts. Okay. Remember that we changed this version 0.8.17 here for 0.8.19 in the previous project. So is this file what I'm speaking about? Okay. Here we don't need to change. It was just for that smart contract frog jump that we were using. If you want to change it, it's harmless as well. But here This file is where we configure everything related to all deployment. And one of the things that you can do is change the default network, okay? This default network configuration that you have in line 33. Instead of being localhost, you can change that to Sepolia, okay? Alternatively, for all the commands that you run, where is my browser again? You could run using this command as well, okay? You have this hint. You could change the default network there in the configuration, or you could deploy by passing this network, for example, to Sepolia or to Linea or to Linea Sepolia or all. Okay, so that configuration could be replaced by running this flag here, like yarn deploy. This yarn deploy, you could do this flag network here, and you would test with whatever target that you want. Okay, it's one or the other. Like if you do both of them, it's going to be the same. You don't need to do both. One or the other is going to do. So you change the default network here for Sepolia. So everything next that you run, for example, this command for yarn deploy, for example, if you try to run yarn deploy now, it is going to try and use Sepolia. Okay. If we try that, if we try yarn deploy now, we have this situation that connected to the Sepolia, we are going to try and deploy your collectible. Let me see here. Yes, I can close this pane. Let me do here the speaker. Let me do yarn deploy. Okay. And we're going to try and deploy. It is going to work. The deploy is going to try and trigger, but we are going to have a problem. Unexpected error occurred. Insufficient funds. When trying to deploy with those pre-funded accounts in testnet networks, like Sepolia, public testnet networks, we don't have funds there. The pre-funded accounts don't work in testnets because testnets are public. And since Web3 is this hellscape of crazy things happening, even if you fund a pre-funded wallet in testnet, people will rob this money. If you try and fund there, ask money from a faucet there, people are going to rob this money. They don't have anything to gain with that. It's worthless, but it will. Try that. Discover that for yourself. People do that. They don't know why, but they do for some reason. And then instead of putting money in this wallet for it to be drained, we are going to create our own. We are going to create our own address here. We are going to create our own account using this command yarn generate. Okay, that is going to create a local account, a local temporary account, or I could reuse that later on. That is going to be the deployer for this smart contract in Sepolia or whatever other chain that I want to try later on. And to do that, I can run this command yarn generate. This command here, yarn generate, before doing the yarn deploy. Yarn generate. That created a new wallet, saved that new wallet to package.hardhat.env file, and then you have this wallet address. Okay. Keep that env file guarded for, like, don't commit it, don't share it, don't show it, don't look at it, don't even open it. Okay, keep it guarded because it's going to have your private key. If you use this later for deploying production, if you use that like a multi-sig wallet or whatever for your project, you are going to be in bad sheets if you somehow leak that. Okay, if you somehow share this with someone else, if you put on GitHub, even if you take back, I don't know if someone saw this or not. So it's going to be inside this folder. Hat is going to have this .env there. It's going to follow this example. It's going to have a key, a deploy private key, TSCN API key. You could change it later, but don't leak the content of this file, because this private key now is going to be loaded here in line 17. If you don't load, it's going to use this default private key that is compromised. But if you have this deployed private key there in your env file, it's going to be used, and this is going to be your account. This is going to be the attached account here whenever you are connected to these networks. It is let me see if I have the end of it. All of these accounts, they're going to be there. Account, deploy private key, and all. Okay. Be mindful of that, please. Otherwise, you could be in bad sheets. You could have your project compromised, okay? If you go for mainnet, or even if you're using mainnet balance here for some reason. Now that you have this wallet generated there for you, you can run this command yarn account to see what is the state of this account for you in this network. Yarn account, you're going to have a QR code. So you have this public address, and it's going to print your balance in all of the networks. Okay, since we have just created it, it's not going to have balance in any of these networks. And Polygon Mobile, I guess it was deprecated 2 days ago. Yeah, so you don't have this connection in Alchemy anymore. Okay. So for example, I'm going to pick this address. I'm going to copy. We need to have balance here in Sepolia. I need to have balance there. So what I'm going to do, I'm going to pick my MetaMask, connect it to Sepolia. Here. Okay. And then I'm going to send, I have 2.8 Sepolia ETH here. I'm going to send to this address 0.2. 0.2 should be enough, or 0.1. 0.1, if I need more, I send more. Okay. So you can pick this money from Faucet. Later on, we're going to connect to Linea. Now just completing the challenge here in Sepolia, and I'm going to send this for funding this account. Later, you can use this account for withdraw this money back for your development wallet. Okay. But for now, and the deployer account is going to be different from your burner wallet address. Okay, they are different things. The account that you use to deploy the smart contracts is different from the accounts that you use for testing up the dApp later. Okay, so this transaction completed, sent here in Sepolia. If I try account again, yeah, an account, it should show a balance different than 0 here in my Sepolia. Yes, showed 0.1. Okay, you can stop this script. Now that I have this money, now that I have a deployer set up and I have money in Sepolia chain, I can do the yarn deploy. That is going to pick this deployer, this address that I just created and funded, and is going to deploy there. It has deployed in this transaction hash this contract here with this EO collectible. Okay, it is on chain. It is for real, not for real because it's not mainnet, but it's getting very real. I can share this now. I can send to friends. Okay, The problem is if I go for localhost, if I try to view these NFTs, view the block explorer and all, it is still having a problem because the Next.js is not reading the configuration of the full chain from hardhat. We changed the file here. This gives some confusion sometimes, okay, people? So we changed this configuration here on line 33 of hardhat, okay, hardhat config.ts. But if you don't know these tools, these different tools, it can get confusing. But hardhat is one thing that is using like behind the scenes in the backend here for managing the contracts, the scripts, deploying to blockchain, running transactions in the blockchain, for setting up contracts and all, yes. But Next.js is another thing. And I know they have some bridges between them, like ScaffoldETH can compile a contract there and automatically uses the types in Next.js. Yes, they have, but the configurations are different. So changing the configuration here for default network at hardhat at the line 33 does not set up Next.js, does not set up the front end automatically to connect to this network. No, we need to do that manually. Okay, we need to do that in the next step. We need now to go, I guess I scroll to top. We need now to go for this configuration inside packages Next.js scaffold.config.ts in the front end, okay? And we need to change the target network to chain Sepolia. This file in Next.js scaffold.config.ts, okay? In line 14, here is target network in the singular, okay? But in newer versions of ScaffoldETH, you're going to find target networks in the plural, okay? And then you have an array here with chains hardhat. Here you just have one target network, okay? This is the only difference from the tutorial to the code that we have. Okay? A simple difference. Instead of being target network, it is networks. And then you're going to change, instead of chain.hardhat, you're going to have chains.sepolia here. Okay, it is imported from VM chains. Okay, that package that I mentioned like an hour ago more, that has all of these abstractions for the things that you want to use on chain. Okay, so if you look here on the definition of chains, you're going to see all of these already maintained, already listed for VM. Okay, so you're going to find a Linea Testnet there, for example, and the definition for Linea Testnet is that you have all of those connections. Okay, I just noticed I didn't look under the hood before, but they are still using Linea Goalie Testnet. We should account for that. But ideally, we would use the Linea Sepolia Testnet for it to work. Okay, you have it there for the Linea Testnet, and of course you have Linea Mainnet with all of the full things that we need. Okay, these chains here are definitions for the front end for using these chains. They are different from these chains here, that the list of chains that the backend, that the hardhat need. Okay, I know they point the same thing out, but those are different configurations. Okay, so for example, we would need to create a network here for Linea Sepolia or Linea Goalie, like we have in Viem here. We are going to deal with that later. So after you change this line 14 with this target network from Viem, changing from chain.hardhat to chain.sepolia, now just that, you just need to change that. When your front end is rebuilt, recompiled, you can go there for your page. Let me reload that. Okay. You don't have Block Explorer anymore. If you click on debug contracts, you are going to see the contracts deployed like for real not for real in Manage, but in Sepolia Testnet. And everything that you try to do now, for example, a transfer, an approve, or whatever, you would do in a real testnet environment. You would need to connect your wallet. You don't have access to that burner wallet anymore. You could even enable if you want, but it's not desired here. You will need to connect your MetaMask or your wallet that you use for development, and you would use your real tokens in that testnet. If you run out of tokens now, you can't just ask a magic faucet here. You would need to go through all of those faucets from providers, from Alchemy, from Infura, and now for having testnet money for testing here. Okay. So this is the your collectible that we deployed a while ago, deployed in the Sepolia testnet. We are going to do this test now. We're going to do this test for minting an item in testnet. Okay. Here the explanation about the burner wallet. Since we are in a public testnet, we are now going to need to connect with a wallet instead of using the burner wallet. Okay. If you want to enable it, it's possible, but it's not so desired. Okay. In this situation, you want to keep using your wallet. You don't want to get a new wallet every time. So having a MetaMask connection is more, or any wallet connection is more advisable here in this situation. If you have access to Testnet Ether there, and you're going to be able to sign these transactions with the wallet. Okay, so let me mint an NFT. It's going to upload the metadata for IPFS. And look here, we are going to need to sign with MetaMask. Using a burner wallet, it doesn't even prompt us for signing. It just signs off anything that we click because it's disposable and all, remember? Here we are going to send this transaction to testnet. We can even check the transaction in the Explorer. It is going to take a while, a few seconds, half a minute perhaps, for it to be confirmed. It was confirmed, it's now indexing. And after we do that, we are going to be able to see this NFT. It is in my wallet. It is in the testnet blockchain in my wallet. I have access to this NFT already, minted here on chain. For example, let's see if they suggest that there. Flex, for example, let me show that this is deployed. So for example, that is the side quest. Let me do this side quest now. Let me prove for you that it is deployed in a public testnet in Sepolia. This smart contract where I'm minting this NFT. This smart contract, I can see that I'm interacting with it, with the mint item function here. Let me click here, your collectible is a token. I can see this your collectible token here in the Etherscan. I'm going to copy this contract address and I'm going to paste it here in the OpenSea. I'm using the testnet version of OpenSea. Okay, so any address that I paste here, it is going to be searched in testnet. And I can see this your collectible that has one instance here that is this buffalo. If someone else has come here, for example, let me disconnect this one. Let me connect another account. Let me connect my test account, my third test account that I have here. If I mint NFTs with this account now, I'm going to see that I have 2 entries here. I'm going to see, let me update this OpenSea page for that collection. It might take a while for it to reflect. But in Etherscan, it's very quick. I can see that I have now 2 in supply. I have 2 holders. No, I did with the same one. Let me see. No, I connected another one, right? So the zebra is owned by my second account. If I connect my first account, I'm going to have the bison here, the buffalo. And let's see if it updated the metadata. Takes a while. Yeah, I have now the zebra and the buffalo. 2 different owners. Okay, 2 different items. Let's see if I can see that in collectible holders. Yes, still showing just 1 holder, but I have those 2 different items, and it's for real. Everything that we are minting here now, it is going for a public testnet environment, and the images are held in IPFS, are stored in IPFS, so it can be hosted decentralizedly as well. I don't need to keep, for example, after minting those 2, I don't need to upkeep my project in anything else. It would be usable by the community, okay? But let's say I want to host, now let's scroll up. Let's say I do want to host that live for my friends, for my judge to see in my project, in my hackathon submission. Now, they have this integration with Vercel already coded in ScaffoldETH. That is one of the cloud providers that you can use even for free for hosting your projects. So for example, I'm going to run this command here, yarn Vercel. That is going to connect to my Vercel account. I'm going to say yes here. My personal account, I do have 2 accounts configured there in that hosting provider. And I'm going to pick my personal account, and I'm going to deploy a new project for it. For example, this is going to be the Linea challenge, Linea NFT, the app example. Okay. So I'm going to pick all of these default. Of course, only lowercase and alphanumeric characters are allowed. So let me do that again. We are in this command here, the yarn Vercel, and I would assume that it would sanitize the string, but it didn't. So yarn Vercel again. Yes. Then I'm going to pick all lowercase now. Linea dApp text. Now that's going to work. Let's see. Correct. Setting up the project. Uploading. I don't want to modify these settings. And this should create, after 30 seconds, 40 seconds, 1 minute, a built version inside Vercel that I could interact with this dApp live. You could send this for your friends, you could share this, you could even have your early users, because anything that we need now from those JavaScript files, from these HTML files that we have compiled, are going to be hosted in a server for us. In this situation, is a free server. It can't hold too many connections without starting to build my credit card, unfortunately. But for a hackathon project, for quick starting a project, it can suit you well. Okay, you are going to have a public link, a public URL with a SSL certificate, with some sort of load balance and all caching versions, edge deployments, all of that for you. Okay, the name of the service that is hosting this is Vercel. You can find it, vercel.com. You can find the explanation of the service here. So instead of picking my company data here, let me switch from my personal profile. Okay. So here are the projects that I have. For example, this is creating a new deployment here. A new deployment what I have here. It is building. So I could see the results of this building here. Let's see, building. Deployment is built. Let me see if I can view the build status. Usually it takes less than a minute. Don't know why it's taking too long here. But it's doing the building part. It is, okay, it's deploying. So it is creating all of this HTML, JavaScript, CSS for us, bundling this all, deploying this output, deployment completed. Okay. Now, if I enter, here I have more than a minute, but here I have my website, my dApp, hosted here in my personal project inside Vercel. But later I could switch for a project for a DNS that I have, a link that I have, and I have the whole app working. Even if I switch it from my computer to web hosted, now when I connect this account, test one, I can see my NFTs there. Let me reload. If I didn't do anything wrong, I see my Buffalo there. Okay, so anyone connecting to this URL would see this Buffalo item hosted there. If you want to complete your challenge now, you have everything needed. Let me close this, close this. You have your front-end work, right? So you go for Speedrun Ethereum. You click here on Submit Challenge. You can put your deployed URL. In this situation, is this URL that I have, and the Etherscan contract URL, your collectible, the contract. Let me just check one thing. Okay, it should be just the address of the contract, okay, like this. So you're going to pick your Etherscan address of this contract, this page, and you are going to paste there in your submission. This is enough for you to submit your first assignment, your first challenge. Okay. They have an automated verification. For example, it's submitted here, this challenge number 0. I had it submitted a while ago as well, but now I have resubmitted that. And they are going to test, they are going to run some automated tests to see if my instance is correct, my contract is correct, my deployment is correct. And now, let me reload. After a while, you could see that as accepted if you did everything corrected. For example, you have the challenge 0 submitted here. Okay, everything working. They do those tests, so they compile, they do the tests. You have 3 tests passing here. It means that your challenge is completed. Here, for example, I have completed the challenge number 1 and the challenge number 2 as well. Since I complete those 3, you have enough to join the Beetle Guild. Okay, you can pledge to join and start contributing and participating. This simple NFT challenge that we completed could now be appended, could now be modified. Let me switch that back for the hard hat local network. Okay, let me, I won't need that deployment address anymore. Let me do this change. I'm going to pick this NFTs metadata that I have inside this repository. I'm going to copy the whole contents from it. copy the whole file from it to define this NFT metadata. To point to that repository that I mentioned a while ago, to that repository, no, to those metadatas from those repositories from eFrogs, and I picked some of these public images from the element market, okay, that you can find all of the collections, the mainnet collections here at this marketplace. You can find all of the hosted images for those beautiful frogs there. Look how cute they are. If they weren't so expensive, I would buy all of them because they are so cute. So you have this resource hosted there publicly. And for educational purposes, we are going to do this. I'm going to copy this metadata and I'm going to paste inside this file, inside packages, NextJS, utils, simple NFT. Okay, can find it there. I'm running out of time. Let's see how far can I go. We're going to pick NextJS, app. No, let me check that again. NextJS, utils, not app. Utils, simple NFT, and you have this NFT metadata. See? And the metadata that we have by default is pointing to the Austin Griffiths repository with those NFTs, with the buffalo, zebra, and all. Okay, we're going to replace all of this file by this metadata that have the description for the eFrogs number 1, 2, 3, 4, and 5. Okay, that is going to have those images and all. And just by doing that, when we recreate our application, let's do that in testnet. Okay, people. I'm going to pick the testnet. No, it's going to take too long. Let's do that in the local hard hat node. So I changed the config here for hard hat, and I'm going to change the configure for the scaffold.config.ts there, and the hardhat.config.ts as well. We're going to change for localhost back. Okay, so we have time for exploring everything. I'm going now to do yarn chain for spinning up the localhost node. I'm going to split the view again, top bottom, for the bottom pane, for me to use this bottom pane for running the commands. And I'm going to run this yarn deploy here. By changing the metadata now of this contract, whenever I go for my local host, okay, let me connect with a burner wallet here. Disconnect that, disconnect. Okay, disconnected. That's not that easy, yeah. I want to connect to a burner wallet, but it is auto-connected to my page. Let me try and force it. Why it's always happening in the last minutes of a lesson, right? So I finally got it to disconnect to my MetaMask, and now I'm going to connect to a burner wallet. Okay, and I'm going to grab some funds from the faucet to ETH, for example. Good. Now, since I changed the metadata, when I mint an NFT, it's not going to be the picture of the buffalo, of the zebra and all. It's going to be the picture that I put in the metadata. For example, this picture of this widely stretched frog. Someone made it twice as wide as it should be here. And if I mint again, I'm going to have another frog minted for me in this test environment. Okay. To fix this, now in the last minute of the lesson, to fix this, we can simply change the files of the HTMLs and the configurations that we have inside those pages. For example, I'm going to edit the NFT card.tsx inside package Next.js component simple NFT. Package Next.js component simple NFT. So I have this component for the NFT card, one of the things that I have inside this file, this TSX file, it is the description of the layout of the page, how the things are going to behave in the page. For example, in line 20, I have this description for how the NFT image is going to behave. And we have a class name here from Tailwind saying that it should be full stretched, full width. And instead of that, I'm going to apply the class of width 60 for it to have 60 pixels, 60 by 60. Just by doing that, when I go for my page again, I have the frogs behaving. I have the correct pictures of the frog in the correct height and width here. Okay, could be improved. The looks of the page could be improved, but what I intended to show here is that now you are free to edit this the app, your NFT collection, your marketplace. You are free to do anything you want, empowered by this Scaffold ETH package, empowered by these tools to safely enter, to safely navigate your the app development journey. Okay. So this is it. This concludes today's lesson. The developing a dApp. The next step would be connecting to Linea, connecting to your wallet, doing the changes for your project, putting your smart contracts here, and perhaps we do another one, Emily. If you think on the next date, we do the cities 3, 4, and 5. If people are interested, then we keep on showing more tricks and more techniques for blockchain development.
Yes, amazing. Thank you so much for joining, Matthias. This is a really comprehensive tutorial. I hope everyone else had a really good time. This is recorded on YouTube for those of you who guys are watching from other channels, like what do you call it? Like Twitter or LinkedIn. So I'm gonna quickly post this kind of in the chat if you want to check it out. It's where it's going to be recorded. I think there was a question, Matthias, about like the GitHub link. If you could reshare that with
Let me
me.
see. Okay. The link is here. Yeah, it was a while ago, like 2 hours and a half ago. Sent you here in the chat.
Okay, cool. And I will post that as well. So here is the, I guess, link for if you want to get all the information on the mini bootcamp. I don't think I have anything else to say other than thank you so much for joining. If you want to like start building on this off of what Matthias built and taught you, our cook-off is happening right now. Our submissions are happening in 2 weeks, so you can learn more here. Anything counts. A dApp, a tutorial, something new, something old, something ongoing. But yeah, otherwise, I think I mentioned this last time as well. The way to get connected with Matthias is, what is your Twitter name? Here we go. Let me pull this up. You can follow Matthias here on Twitter. And yeah, I think
Great
that's
stuff.
everything. Cool.
Let's see what those devs get cooking, right?
Yeah, let's get cooking. Okay. So I guess it's time to hop off now. So thank you so much again, Matthias.
Was a
And thank
big
you everyone
pleasure.
else who
Thank
was
you all.
watching. Okay.
Bye bye.